this is one of the properties of square roots, of course, or one of the functions, is to simply take the square root of a number. And for example, to take the simplest one I can think of, taking the square root of 4 makes the square root of 2 squared. And when you get the square root of something squared, you simply take it outside of the surd, and that's the number. The base is the number. So the square root of 2 squared is 2. And this is true if you mix numbers about by multiplying them under the surd. So a squared b under the surd would be equal to a root b. So the square root of 12 would be the square root of 3 times 4. 4 is 2 squared. So you can take the 2 outside and it becomes 2 root 3. And also take another example, the square root of 27. Again, another simple example. 27 we know is 9 times 3, and 9 is 3 squared, so we got 3 squared times 3, and one of those 3's can come out, leaving a 3 underneath the surd to make 3 root 3. The square root of 162, however, we can, well, 162 is an even number, so that can be 2 times 81. 81, well, we know that to be 9 times 9, so we can say root 2 times 9 squared, and one of the 9's can come out, and we can end with 9 root 2. To take even more examples, like let's say we have the square root of 25. Well, that's the square root of 5 squared, and that's 5. We already seen an example like it. How about the square root of 75? Well, we can say that's 3 times 25, and we already know what the square root of 25 is, and we already know that a 5 can come outside of the surd, and so we can say that that's 3 times 5 squared, or 5 root 3. Another property of square roots has to do with the square root of a fraction. So we can actually distribute the square root to the numerator as well as the denominator. And to take some, once again, rather low-level examples, we can say the square root of 3/4. Well, that's the square root of 3 divided by the square root of 4. Now you already know that the square root of 4 is 2. And the square root of 3 we can't do anything with, so since 3 is a prime number, and so we end up with the square root of 3 over 2. Square root of 7 over 8, square root of 7 divided by square root 8. 7 is prime, so that stays as square root 7. And it's divided by the square root of 8, which is the square root of 2 cubed, which really is just 2 root 2 in the end. And of course we can take the square root of 7/3. This time both the top and the bottom are prime. So this stays as root 7 over root 3. But maybe there's a little problem with having a root 3 in the denominator. So we can actually multiply that by root 3 divided by root 3. And root 7 times root 3 is root 21. But root 3 times root 3 is just 3. So we get 21 over root 21 over 3, which is a more correct way of representing the square root of 7 over the square root of 3. Now what about square roots with factors in them? So if I have a root b and c root b, I can factor out root b outside of a plus c and just add a and c together. So here's an example. So let's take 3 root 3 and add it to 5 root 3. Intuitively, I just like to show the operation in a very stepwise fashion. Most of you would probably just do this in one step, but we can actually factor the root 3 out of 3 plus 5. 3 plus 5 is 8, and we end up with 8 root 3. Now, what about polynomial expressions? Something like a quadratic underneath a surd. Well, this quadratic just happens to be a perfect square. X squared plus 2x plus 1 factors to x plus 1 quantity squared. Now, under a square root, that comes out nicely. And so the square root of x plus 1 all squared is just x plus 1. Now, x squared minus 5 isn't really a difference of squares in the traditional sense, but we can certainly treat it that way, and it factors into x plus root 5 times x minus root 5. It's not really a perfect square, nor is it a difference of squares, but we certainly treated it that way. Now, to be precise, this is really more like a common error to avoid. Root x plus y, in other words, where x plus y is under a surd. I've seen a lot of people re-express this as root x plus root y, and there's no way that you can separate these. And I'm going to show you an example. How about if I take the square root of 81 plus 9, which adds to 90, but I'll say that it's equal, or I'll pretend that it's equal to root 81 plus root 9. Well, root 81 is 9, and root 9 is 3. 9 and 3 make 12. Now, if you work out the other side, it works out to 3 root 10. Well, 3 root 10 is not 12 by any stretch of the imagination. We can see that it is not equal. However, the products of two square roots can certainly be combined. You can break up root xy into root x times root y, or you can say root x multiplied by root y is root xy. So this is like root 3 times root 4 being root 12, but we already worked out what root 12 was. Remember, that was 2 root 3. And that's because you probably could have figured out right away but that the square root of 4 was 2. How about root 6 times root 7? Well, root 6 times root 7 is root 42, and you can't really simplify that. How about root 4 times root 16? Well, that makes root 64, and that turns out to be root 8 squared, which is just 8. But of course, you could also figure out that root 4 is 2, and multiply by the root of 16, which is 8, or sorry, 4, and 2 times 4 would be 8 as well. How about solving the following problems without a calculator? And these are just simple numerical calculations. The square root of 80. Pause the video and maybe write down your own answer before you proceed. Okay, I'm back again. So the square root of 80 is like 2 times 40, which we can take out another 2 out of that 40, and that's 2 times 2 times 20. Now we can keep taking out 2's out of here, but I'll just save you the trouble. This ends up to be, well, 20 breaks up to 2 times 10, which is 2 times 2 times 2 times 2 times 5 when we work it all out. So that means we have 2 to the 4th times 5. Now 2 to the 4th under the square root becomes 2 squared outside the square root, and the root 5, because it's prime, stays underneath, and 2 squared is 4. We end up with 4 root 5. Okay, next question. How about the square root of, say, 56? Once again, before you move on, just pause the video and write out your own answer. Okay, the square root of 56 is the square root of 8 times 7. And, well, we know 8 to be 2 cubes. 7 is prime. And a 2 can come outside. There's a 2 left underneath the surd. And that's 2 root 2 times 7, or 2 root 14, which is really the answer to square root 56. Once again, without a calculator, how about 6 multiplied by the square root of 126 divided by the square root of 18. What does that equal? Once again, pause the video and restart it once you have your own answer. So we can take the 6 outside the fraction, and 126 over 18 could be combined under a single surd. And that can become useful because we can actually cancel some terms this way. So keeping the 6 outside, the 126 can become 2 times 63, and 18 is like 2 times 9. And notice that a 2 is common on the top and on the bottom of the fraction, and we can cancel them out. We end up with 63 over 9. So 6 times root 63 over 9, well, the square root of 63 factors into 9 times 7. And we got 9 times 7 over 9. And now we see that the 9 is common on the top and the bottom, and they cancel, and we end up with 6 root 7.